Hello, everyone. All right, so the second lesson is going to be focusing on what we call domain and range. So I will say this is a very important lesson, probably one of the most important lessons we will cover this year. No pressure. All right, so domain and range is really going to focus on honing in on the x values and y values of the specific functions. So as mentioned before, so domain really is going to focus on the x values, whereas the range is going to focus in on the y values. So we have two different types of functions. So we have what we call a continuous function, and then we have what we call a discrete function. So a continuous function, I'm going to go through first. So it's just a function that can be graphed by a line, whether it be straight or a curve. So for continuous functions, these are going to be represented using inequalities. So we're going to be bringing back 1D lessons for this lesson very quick. So we have a few examples of continuous variables. So we have things like volume, distance, and time are going to be the common ones. So a good way to picture this and ask yourself, if something is continuous, can you have a part of it? So think of it this way. If you're talking about hours, you can have a part of an hour, you can have minutes. You can have part of a minute, you can have seconds. You can have part of a second, you can have milliseconds, and just keep taking parts and parts. Volume, you can have, for example, let's say you're filling the volume of a pool. You can have so many cubic gallons, and you can have, like, for example, half a gallon, or you could have a fourth of a gallon. So you can have quarts, pints, cups, and fluid ounces and whatnot. So you could have part of that measurement. So that's what makes that continuous. And distance, the same idea. So a good example is you can travel, say, 5.3 miles to reach your destination. So you can travel that part of a mile or kilometer or meter or whatever have you. So continuous functions are really going to be represented using either a straight line or some form of a curve. So it's where everything's going to be connected. So ideally, the continuous functions are literally so many individual points that are just put together so compactly that it literally just forms a line. So whenever we're looking at the domain and range of continuous functions, we're looking at inequalities. So you always want to follow this specific little format here. So you always want to have the minimum value on the left and the maximum value on the right. Okay, so if you're talking about your domain, you have to have x in the middle. If you're talking about range, you want to have y in the middle. So just like before with your inequalities, your inequality signs here are always going to be opening to the right. They will both, and for both domain and range, they will both always be opening to the right. So one thing to note about your inequality signs here is they are interchangeable. So what I mean by interchangeable is you could have, say, an equal sign here and an equal sign here, or you could just have it on one. You could have it for the minimum, or you could have it for the maximum. So you could have it on one, both or neither of your inequalities. So same thing goes for your range. So that's what all that is saying down there. So some of your continuous graphs, so this won't apply to a lot of problems. So let's say we have a graph that's continuously going to the right, which we're going to cover this and what this looks like. So if you have a value that's just continuously going in one direction, we're going to name it as infinity, which is literally just an 8, but on its side. So you could also rewrite this compound inequality using a simple inequality. So just be aware that some of those inequalities and the way they're written can be interchangeable. All right, so that covers continuous. Now we're going to look at what we call discrete. So a discrete function is essentially a function, but it's disconnected. So it's just a series or a set of points. So in order to represent the domain and range of a discrete function, we're going to use what we call brackets. But more specifically, they're curly brackets. So we're going to be using these curly brackets. I can always draw the right one so much better than the left one. I don't know why. So we're going to be using those, but if you draw your brackets like this, those are incorrect, and you will technically get points off for using those. So please be aware. So please ensure that you are using curly brackets. And I'm not gonna lie, they may take some practice to draw. I'm not saying you have to draw them perfectly, but even if you just even just a squiggle, I will take that. Okay. So just some examples of some discrete variables. So the best objects I can really tell you are just anything that's a physical object. So desks, baskets, chairs, tables, hats, phones. So just anything that's an object. So like an Apple Pencil. If you're going to buy an Apple Pencil, you're not going to buy half of an Apple Pencil. You're going to buy an Apple Pencil. You expect the whole thing to come in a package. iPads. You would expect to buy an iPad. You don't want to open an iPad box and literally only half of the iPad is there. Pretty sure you'd want your money back. So point being is just, it's something that you want an actual physical item in which you cannot have a part of. Okay. So once again, these are just a set of points. So it could be represented in a straight line, could be a curve. These points are off. They should be. There we go, close enough. So once again, domain and range, they are going to be listed from least to greatest, no repeating values. That should sound very familiar from 2A when you're doing mapping. So those two things should not be anything new. So one thing to definitely keep note of is the use of the ellipses. So if you're going to use an ellipses, you have to make sure it's actually going to be non-terminating, like it's going to go on forever and ever. So if it is a non-terminating function, then you want to use an ellipses to represent that it's going to keep going and follow that pattern. However, if it does terminate, like if it eventually stops, then you don't want to use an ellipses or ellipse or ellipses, whatever. I don't teach English. All right, so a good example for a terminating one would be volume. So if you're filling up a pool, eventually the pool's going to be filled, which means eventually your function's going to stop, which means there's no ellipse or ellipses, whichever one. Okay. However, if you're trying to sell objects, ideally you'd want to sell as many as possible. So in that case, in a real world perfect example, let's say you sell 10,000 objects, or you could say sell 10 million objects. In that case, you ideally would not want it to stop, so it would be continuous. So in that case, you would want to use an ellipses, unless you really want to write out 10,000 values, which I highly doubt you do. I'm sure you have better things to do. So an important note to really talk about in these functions is you always want to assume that functions are going to be discrete unless it is stated otherwise. So what that means is if I just give you raw data in terms of numbers, you have to assume it's discrete. However, if I give you, say, a word problem, and the two variables that we're talking about, if they fall under the continuous category, then you would say it's continuous. Otherwise, assume it's discrete. Okay. All right, so we're going to practice this. So I want to find the domain and range of the following. So I'm going to use the different representations from 2A. So here we have an order pair. So remember, your domain is all your X values and all your range represents your Y values. So for the domain, I'm looking at 4, 5, 6, and 7. So once again, least to greatest, no repeating values. So I'm going to open up my curly bracket. It's a terrible curly bracket, but it's fine. All right, so from least to greatest. So 4, 5, 6, 7. So I only have 4 data points, so it is terminating. So I do not use an ellipses. And I only have 4 points. I got all my points. So now I'm going to close it using a right bracket. So there's my domain. Now I want to look at the range. So I'm looking at the Y values. So same idea, no repeating values, least to greatest. So I'm going to open up a left bracket. So you want to start from the smallest value. So notice how we have 1 written twice. So I only write it one time. So 1, comma, 2, comma, 3. Why are my commas like that? Close enough. All right, and close. That's a terrible bracket, but it's okay. All right, so there's your domain and range. So your domain and range is not always going to have the same number of elements. So when I say elements, an example of an element would be 4, 5, 6, and 7. The actual numbers inside the brackets are what we call elements. So your domain has 4 elements, whereas your range is going to have 3 elements. All right, so now let's look at a table. All right, so for your table, once again, we're looking at domain, which is your x values. So least to greatest, no repeating values. So I'm going to open up curly bracket. That's terrible. That is still terrible. It's less terrible, still terrible, but I'll go with it. All right, so we want to start with the smallest values. So -2. So that takes care of that one. Then the next value would be 0. Takes care of that one. All right, so 1 is written twice, but we only write it once. So that takes care of both of those. And then we have 3. All right. So even though we have 5 data points here, we only have 4 elements within the domain. All right, so now looking at the range, so we have 2, 3, 4, 5, and 2. All right, so I'm going to open up a left bracket. Wow, that is terrible. Everything's fine. All right, so starting with the smallest, so we're going to start with 2. So 2 is written twice, so that one's done. Then we have 3, 4, 5. So 3, 4, that's a terrible comma, and 5. My right brackets are always so much better than my left ones. I don't know why. I think it's because I'm left-handed. Anyways, so even though we have 5 data points, we only have 4 elements in both the domain and the range. Okay. So notice how we're writing them in curly brackets. We haven't even once used inequalities. So those will be coming soon. All right, so now looking at mapping. So a little FYI here. There was supposed to be an arrow up here where that orange arrow is. All right, so here's the thing. Doing domain and range for your mapping is actually the easiest one because a lot of the work is already done for you. Whenever you're doing mapping, the same idea happens where it has to be in order from least to greatest with no repeating values. So they've already done the work for you. You literally just have to copy and paste the numbers. So for the domain, I'm going to open up my terrible left bracket. Wow, it's slightly less terrible. Okay, and you can literally just write your numbers exactly as they appear. So 0, 1, 2, 3. 0, 1, 2, 3. Okay, that is a great curly bracket. Anyways, sorry, little things. All right, now looking at the range. So same exact thing, open up my terrible left bracket. So 2, 3, 4, 5. Okay. So as mentioned before, with mapping, it's the easiest one. You just copy and paste the numbers because they're already in order from least to greatest with no repeating values. It's already done for you. Okay. All right, so now for a graph. So the graphs for domain and range are where a lot of the rigor comes from, a lot of the difficulty. All right, so I will start just by identifying all these different points. So you don't have to do this part, but as you're still kind of being introduced to this topic, I would highly recommend it. And as you get better and more comfortable with domain and range, then you can, I would say, skip this step. But I'm actually going to write the coordinates for each of these points. So we have -3, -5. Then we have -2, -3. Then we have -1, -1. 0, 1. 1, 3. and 2, 5. Okay, so once you actually identify and write out the coordinates for each of these points, then it's literally just the same as what we did up here. So I'm going to open up brackets for the domain. So one thing that is good about the graphs is a lot of these will be done in order for you already. So if you notice, we're just looking at the x values for the domain. So -3, -2, -1, 0, 1, and 2. So they're already in order, just go from left to right. So -3 to 2. -3, -2, -1, 0, 1, 2. And close. Wow, that is terrible. There we go. I don't know why it's like curving down, but everything's fine. All right, so now for the range. So now you're looking at the y values. So -5, -3, -1, +1, +3, and +5. Okay, so once again, I'm going to start from the smallest values. I don't know why I'm using Christmas colors, but I am. All right, so start with -5, then -3, -1, +1, +3, +5. Wow, that is terrible. There we go. Still terrible, but it's fine. Okay, so there's your domain and range of a discrete graph. Okay, so these are all discrete. Now we're going to actually go into continuous graphs. This is where a lot of the confusion actually comes from. So we have what we call boundaries. So boundaries are what we look at in terms of the graph. So we want to look to see, do we have any arrows? So if you look at this one, we have 2 arrows on both sides of our graph. So it doesn't stop, it doesn't have an endpoint anywhere. So this is what we call no boundaries. If you look at the second one, notice how we have an endpoint and 1 arrow. So that is 1 boundary. So the boundary is going to refer to the number of endpoints that we have. So we only have 1 endpoint, thus 1 boundary. All right, and then 2 boundaries, we have 2 endpoints, 1 here and 1 here. Okay. All right. So if you're one of those people asking, well, can you have more than 2 boundaries? You actually can. That's when we get into piecewise functions, which is algebra 2, which I will save that for later. That is beyond our scope for right now. Okay, but for right now, we're looking at no boundaries. So this is a continuous function, which means we're going to be using inequalities. So here's the thing. I always kind of break this up into a smaller dimension. So I write the domain across the top, and I'll write the range across the right side. So, because remember, for domain, we're looking at the x values, and the x values represent how far left and how far right we're going. It's probably backwards for y'all. But if you notice, because we have no boundaries, it's going to go on infinitely in both directions for the x. So infinitely left and infinitely right. And then for the range, same idea. It's going to go infinitely up and infinitely down. So what that means is for our domain and range, because it doesn't stop, we're actually going to hit every single number that is humanly possible. So another way of saying that is all real numbers. So that is both for the domain and the range. So what I'm going to do, instead of having to write all real numbers every single time, what I'm going to do is I'm actually going to write the symbol for all real numbers. So it is a capital R with another vertical line going down. Oh my gosh. There we go. Close enough. So it's going to be both for the domain and the range. So once again, that just means all real numbers. Okay. All right, now for 1 boundary. So hopefully the actual representation will make a little bit more sense. I'm sure that was probably a little weird. Okay, so for the domain, once again, I'm going to write it across the top because the domain represents the x values in which we're looking to see how far left and right it goes. Okay, so if you look, we have an endpoint over here. We have an open circle. So what I'm going to do, I'm actually going to write that open circle up here in the top and see how it's actually at -3. So I'm going to label that open circle -3. And then because it has an arrow and it's going to the right indefinitely, then I'm going to give it another arrow up here for the domain. All right, so I'm going to go ahead and stop here, and I want to actually show you what that means in terms of the domain. So in terms of the domain, what this means is I want every number that is bigger than -3. All right, so what that means is I'm going to write my minimum value on the left side and my maximum value on the right side. So my minimum value is -3, and because it doesn't stop going, it's going to be infinity. Okay. So you can rewrite this as x is greater than -3 as a simple inequality, but if it helps to visualize the boundaries and the minimum and maximum values better, I would actually say write the compound. All right, so let's look at the range. So for the range, we want to see how far up and how far down it goes. Okay, so I'm going to start with the minimum value. So if you look, let's just kind of get a visual. So looking at this graph, it goes all the way down to -2, but it doesn't go past -2. So that tells me here that my minimum is -2. And because I have an open circle, I'm going to drag that open circle over here. I'm going to name it -2. I'm going to give it a special little name. Okay. Now, if I bring that line back, now you want to see how far up it goes. So I'm going to drag my line up. So for example, if I stop it here at 1, well, it still goes a little bit higher than 1. So 1's not my maximum. But if I go up more, if I go up here, that reaches the highest point of my function here. So that means that is my maximum. So now if you look, notice how there's no circle, there's no opening here. So what that means is I'm going to draw a closed circle. So that closed circle reaches a value of +2. So now I want to relate all of this information right here into an inequality. Okay, so I'm going to write my format. All right, so my minimum value is going to go on the left. So my minimum value is -2, and my maximum value is +2. Now, if you look, we have a closed circle at 2 on our maximum value. So that means we can be equal to that value. So what that means is I need to give that an equal sign. So that would be my domain and range here. So notice here how I can't rewrite this one as a simple inequality. That's because this one doesn't have either -infinity or infinity as a min or max. If it has -infinity or +infinity as one of the boundaries or one of the maximum values or minimum values, then you can possibly rewrite it. But in this case, we can't. Okay, now we're going to look at two boundaries. So in two boundaries, once again, we're going to start by looking at the domain. So you don't have to write the D and R values on the side. I just do that for you guys. So I'm going to do similar to like a vertical line test. So just to kind of give you guys a visual of to where it starts and where it stops. So I want to find the minimum value first. So I want to start on the left. So right here, it starts at -3. So what I'm going to do, it has an open circle. So I'm going to do open circle at -3. And now I want to go see how far to the right it goes. So I'm going to take that line and I want to go see how far it goes. So right here, it stops at 1. And notice how it has a closed circle. So I have a closed circle at positive 1. Okay, so there's the domain. All right, so now let's look at the range. So remember, for range, that's going to represent how far down and how far up it's going to go. So I'm going to start from the bottom. As always, started from the bottom. Now we're here. Or if you're me, you started from the bottom and somehow got lower. What the heck? Go away. There. Okay. So in this case, if you look to see at the very bottom, we start here at -3. So notice how we don't have an open circle. You actually assume it is a closed circle unless they give you an open. Assume closed unless they give you open. Okay, so go away. Now I want to see how far up it's going to go. So good. It's going to go all the way up to right here at 3. Okay, so once again, it doesn't have an open circle, so you assume it has a closed circle. That is at 3. That is crooked. Everything is fine. Oh my gosh. There we go. Okay. So now that I have the boundaries, I didn't write the R. There we go. So now that we have the boundaries written, now I'm actually going to write the domain and range. Okay, so I'm going to go ahead and rewrite just my format. So I want the minimum value on the left and the maximum value on the right. So the minimum value of my domain is -3. And I can't be equal to it, so I don't write the equal sign. Then my maximum value is +1, and I can be equal to it. So +1, and I can be equal to it. So that's my domain. All right, and then for the range, once again, start with the minimum value and then go to the maximum. So we have a minimum value of -3. So minimum value of -3, and I can be equal to it because it's a closed circle. And then a maximum value of +3, which I can be equal to it because it is a closed circle once again. So there's our domain and range. Okay. So I gave 3 problems to actually try. However, we're obviously not in class, so it's hard to do your own. But here's what I'm going to do. I actually gave you this preset function for a continuous function, and I just gave you those points for a discrete function. So I would actually say pause here, try this one on your own. Okay, so for your domain, once again, you want to see how far left and right. So you have a closed circle over here, and it goes all the way to an open circle over here. So this is -8. And if I can count, 1, 2, 3, yeah, that's 4. Hopefully I can count. All right. So that's your domain. All right, and for your range, started from the bottom, somehow got lower, just like my life, everything's fine. All right, so our minimum value at -1. And our maximum value, we have a closed circle at +8. Of course, it's not going to line up. Excuse me. All right. So when you get to this point, now we can write our domain and range. So from -8 to 4, so -8 to +4, and I can be equal to -8. So -8 needs the equal, but 4 does not get it. It's because it's an open circle. All right, now looking at the range, we're looking from -1 to +8. -1 to +8. And we can be equal to +8, but not -1. Okay. All right, so now if you look at this next one, we have a series, or not a series, we have a set of points. So that set of points, that's going to tell you this is discrete. So because it's discrete, now we have to use curly brackets. Okay, so I'm going to take a second and actually go through and label all these points. So this is -4, -5. All right. So for the domain, remember you want all the x values. So -4, -3, -4, -2, +2, +2, +4. So you want to go through and list those values in order from least to greatest with no repeating values. So you can start from the left and just work your way to the right. So I'm going to start by opening a terrible left curly bracket. Yep, truly terrible. All right, so now I'm going to start with -4. So even though the -4 value happened twice, remember you only write it once. Okay, so then your next value is -3, then -2. Then we have 2 twice, but we only write it once. And last but not least, 4. And close. All right, now for the range. Now for the range, you can actually start from the bottom and then work your way up. So -5, -4, 0, 2, 2, 2. So -5 is our first value. So I'm going to open a left bracket, then -4. Okay, and then we have 0 and 2. Oh my gosh. There we go. All right. So now we have this discrete function. So I would actually say pause here, try this one on your own. Or don't, everything's fine. So this is -5, +9. Math is hard. That's a 1. Counting is hard. Everything's fine. Okay, so now I'm going to do my domain and range. So remember your domain is all your x values. So -5, -2, +1, 4, 7, and 10. So literally in that order, exactly how I said it. That is your domain. Okay, so start with -5, -2, 1, 4, 7, and 10. Okay, and then the range is just the y values. So we have 9, 7, 5, 3, 1, -1. So remember, the least to greatest. So you actually have to start with -1. So -1, 1, 3, 5, 7, and 9. Okay. So I'm actually going to come over here. I'm going to do a couple more examples of the continuous. So you can either write these down or you can just watch and listen. It's kind of up to you. There's a couple that I would actually like to go through. So let's say I do an open circle. Let's do that. Okay. So for the domain, you want to see how far left and right it goes. So just an example. Wow, that is crooked. That is still crooked. There we go. Okay, so I'm going to start here. So that number is -4. Excuse me. So an open circle at -4. Now notice how it has an arrow going down. Now remember, an arrow means it's going to go on continuously forever and ever and ever. So that means it's going to go, yes, I'm going to be that extra. So it's literally going to go all the way down that way. So notice how it never stops going down to the right. So that's kind of a better visualization. Oh no. So you can see that it's always going to continuously go to the right. Okay. So now for our range, this is actually the tricky part of this question. Because a lot of people just want to start by saying, oh, well, here's the endpoint, so this is the range. Not quite. So we have an arrow going down, so we know it's going to go to -infinity. However, now we want to see how high it's going to go. So it's actually going to go up. So here's 1, 2, 3, 4. So the endpoint's at 4. However, our function still goes higher. So 5, 6, 7. It actually reaches all the way up here. So it's actually going to be a closed circle at 7 and go down all the way. Okay. So in this case, for the domain, we have a minimum value of -4. So we cannot be equal to it, and a maximum value of infinity. So here's a little question for you. Can you ever be equal to infinity? Answer, no. You can never be equal to infinity. Infinity is not actually a number. It represents the idea of the biggest number. Okay, so, and then here, looking at your range, our smallest value is actually -infinity. So whenever you're writing your value, please include the negative. Because if you write positive infinity, you are contradicting yourself. Okay. Then our largest value is 7 with a closed circle, which means we can be equal to it. So this would be your domain and range of this function. Okay. All right, so I'm going to move on to the word problems. All right, so a test is worth a total of 100 points. Each time a problem is missed, the student loses 10 points, assuming the test is multiple choice with no partial credit. So this part over here is actually super important, assuming the test is multiple choice with no partial credit. So I'm going to save that part for later, but just kind of keep that in your mind. All right, so let's kind of go through these parts. So does the scenario represent a function? So think about it. Can you miss 3 questions and then 3 questions? Nope. So this is a function. Okay, so is this continuous or discrete? So here's the thing. If it's a multiple choice with no partial credit, can you miss 2.5 questions? Can you miss a part of a question? The answer is no. If it's a multiple choice with no partial credit, it's very cut and dry, which means this is discrete. So your x value, so you want to determine your x value. So your x value represents the number of problems missed. So if you got 0 wrong, you get 100. If you got 1 wrong, you get a 90. If you get 2 wrong, you get an 80, so on and so on. So kind of think about what I just said. Now, what does y represent? So y is actually going to represent your score. All right, so now you want to represent the domain and range. So remember, x represents the number of questions you missed. So if there's 10 questions, here's the tricky part. Well, tricky. A lot of people intuitively will start at 1. But here's the thing. When you're taking a test, you can get a perfect score. which means you actually can get 0 wrong. So you actually, in this case, start at 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's the thing. If you don't want to have to write out an extensively long set of values like this, you actually have another option. It's kind of using the ellipses. So you could also represent it, wow, terrible brackets, using, so 0, 1, 2, comma, ellipses, and 8, 9, and 10. Okay. So what you are going to be required to do is in the beginning, you have to write 3 elements. And at the end, you have to write 3 elements. Okay. And then the rest of them in the middle, you can just represent using an ellipses. Okay. So you have to have 3 in the beginning, 3 in the end. So if it's, I want to say if it's like 9 or more total elements in the domain or range, then this would probably be more feasible if there's a pattern. However, if it's a random spurt of numbers, like if it's like 3, 5, 6, 9, 20, 25, if it's a random pattern, I would not do it. You would actually need to list those out. But if it follows a specific pattern like this, then you can use this notation. All right, so similarly for the range. So if I write them out, so if I miss, so you want to be able to write them out in order from least to greatest, no repeating values. So what's the lowest score you can ultimately get? Well, tragically, you can get a 0. So then 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay, so once again, if you want to do the shorter notation, just remember 3 elements in the beginning, 3 elements at the end. So 0, 10, 20. Then 80, 90, and 100. So remember, if you are wanting to write the condensed bracket version of this over here on the right side, you can, as long as it follows a specific pattern. If it's just a bunch of arbitrary values, you cannot do it. Okay. So if you're unsure if you can, I would just say stick to this. Okay. All right, so now you want to determine how would this problem be different if partial credit was allowed. So here's the thing. In this case, now you can miss a part of a problem. So what that means is this problem would then become continuous. So your domain would be from 0 to 10. When you miss, you can miss up to 10 questions. And then your range would be from 0 to 100. So it just changes the way that the problem is represented. Okay. All right, so question 2. So Kara is filling a 5-gallon cooler with water at a steady rate. The cooler is empty to start with and is full after 5 minutes. So now we want to determine, does this represent a function? Yes, it does. Because here's the thing, we're looking at time. Time is always going to be your x value. Can you repeat 3 seconds? Like if I'm at 3 seconds, can you have 2 gallons and then all of a sudden go to 5 gallons? You can't skip time. It's continuous. Okay, so as mentioned, it's continuous. Because remember, think of time and volume. You can have a portion of it. Okay, so x is time. So what is our time? Minutes. So time in terms of minutes. Okay, and then our y value is going to be volume. in terms of gallons. Okay, so here's the thing. Because this is continuous, we're going to be using inequalities. Okay, so they use it for 5 minutes. So that's going to be our maximum. So when you start filling it up, you're at 0 minutes, and it only takes 5 minutes to completely fill it. Okay, now for your range, now we're looking at the volume. So it's a 5-gallon cooler. So in this case, whenever you start filling it, it would be empty, which means you're going to start with the volume of 0, which is empty, and it has a maximum English is hard. A maximum English is really hard. A maximum volume of 5 gallons. Okay, so a lot of these problems with domain and range, they actually give you all the information you need. You just have to represent it in what they're asking. Okay, number 3. Strangely enough, I would actually say this is the hard one. All right, so a car is traveling at a rate of 70 miles per hour for 5 hours. So is this a function? Absolutely. Because once again, we're looking at We're looking at time and distance, and both of which you can have a part of, which means we are continuous. Okay, so X is going to represent your time in terms of hours, because miles per hour. So Y is going to represent distance in terms of miles per hour. All right, so they're traveling 70 miles per hour for 5 hours. So in this case, if domain is your X value, they're traveling for, So if you haven't even started driving yet, you're at a time of 0, and they're driving for a total of 5 hours. So that would be your domain. So that being said, if you haven't started traveling at all, then your range would start at 0. Now your maximum value, a lot of people make this mistake every single time. If you put 70, you are wrong. Okay, let me tell you why. They're traveling 70 miles per hour for 5 hours. So 70 miles for 5 hours. So they actually traveled 350 miles. So your maximum value is 350. Okay, so people habitually will get that part wrong. So for 5 hours, that's the key part here. Okay,